All right, so it says write functions from tables. So we've done explicit formulas from tables, and now we're going to write functions from tables. And there's a couple ways we can go about that. So here are some basic, you really should pause right now and write these down. I'm assuming you hit pause and write this down, but basically it's saying, define the explicit formula for an arithmetic sequence or table. You want the difference and the first term, and this is the formula, correct? If you want to write it as a function, what you need is the difference and the zero term. Now, if you can get that, you can get it from here and simplify it down, but if you can find the zero term, that's a cheat. And we're going to talk more about that. I'm going to do it both ways, and I'm going to show you why it's easier. With the explicit formula, to do for geometric, I need the rate and the first term. That's how we set this up. You can simplify it all, and you notice that when we did the explicit formulas for geometric, you probably got nervous when we had to simplify fractions and negative exponents. Well, there's a cheat. If I can get the rate and I can get the zero term, also known as the initial amount, I don't have to simplify. I can just write zero, the initial amount times the rate to the x. So we're going to keep that in mind as we're going. Hopefully you've written this down. This should be in your notes. This is a godsend. All right, here we go. Boom. I have an equation. I have a table. The table is in sequential order. Mr. Nelson once said, think of the terms, the x as the term. So this is the zero term, first term, second term, right? And then we're going to see, is it getting bigger or smaller? It looks like it's getting bigger. First, we're going to try addition. Plus 3 gets us to 3, and plus 3 gets us to 3, so we have a common difference. So the first term is 3, and the difference is 3. And so if we were writing the explicit formula, we would write a sub n equals the first term, which is 3, plus the difference, which is 3, times n minus 1. Now, if we want to turn to a function in there, we could. We could go f of x equals 3 plus 3 times x minus 1. And then we talked about simplifying by distributing. It's a lot of work. 3 times x, 3 times negative 1 is negative 3, plus 3 equals f of x. And then finally, what are our like terms? 3 and negative 3 can be simplified. We get f of x equals 3x plus 0 or just 3x. So that's pretty straightforward. Now, I'm saying you can turn this into a function this way, but if you paid attention a second ago when I gave you that formula, to find a function, I need the zero term, or the initial amount, and the difference. Well, I know my zero term, and even if I didn't have zero term, I could probably go back and find it, is this times 0, and my difference is still 3. And then I just do f of x equals the difference x plus a sub 0. Well, look at this. F of x equals the difference 3x plus 0, or just f of x equals 3x. Both give me the same answer, and one gives me, like, literally half the work. So, I recommend this one, but you can always get to this way if you struggle. All right, Mr. Nelson, show me how it's done.
All right, let's try this one now. Use what you wrote down in your notes, like Mr. Craig told you to, and see if you can do this one. All right. Now, there is something a little fishy about this one. We're given the first term, the second term, and the third term. So all those formulas required, like if it was an explicit formula, it required the first term. But if it was the function, it required the zero term. So you might just go with the explicit formula and just simplify that, solve it down for the function. Or I can actually work backwards on this one to go find the initial amount. And so I'm going to do it both ways again, and then we'll probably just go from there and do it the faster way. So let's start with this the regular old explicit formula. Explicit formula requires the first term and then either a common difference or a common ratio. And my first term is negative 4. And let's go see how we go. I see this is sequential, and what that means, or incremental. It's doing plus 1 each time, so that's good. Let's go and figure out what's going on here. I see that it's decreasing, going down. We're going to try addition or subtraction. In this case, subtraction the first time, and that is subtract 3. Negative 4 minus 3 is negative 7. And if I subtract 3 again, I do get to negative 10. So we do have a common difference here, and that common difference is a negative 3. And so if we take that and put it into difference, means arithmetic formula, first term plus the common difference times n minus 1, and substitute in, we get our first term, which is negative 4, our common difference, which is minus 3, times n minus 1. I'd have my explicit formula, but that's not what it's asking for. It's asking for the function. So now I'm going to rewrite it as a function. F of x equals -4 minus 3 times x minus 1. And now we need to simplify, which starts with distribution, right? So we have f of x equals -4. We're going to distribute this -3. -3 times x is -3x, and -3 times -1 is a +3. And then we combine our like terms of -4 and +3. And what we end up with here is f of x equals, I'm going to bring down my x terms first, -3x. Combine my like terms, -4 and +3 is a -1. And now I have my function notation that's nice and simplified for us. And we can see my slope and my y-intercept. The other way to go about this would have been to notice that it has a common difference, and that's arithmetic. And we know that that would be f of x equals dx plus our initial amount. Kind of like mx plus b. But we have a common difference in our initial amount. But we've not given our initial amount. But I could work backwards here. If I'm minusing 3 to go this way, what do I have to do to go this way? Right? To go backwards, to undo a subtraction, we would have to add 3. And so to kind of think about it this way, ignore this for a second. If I wanted to get back to my initial amount, to where it's 0, I'd have to add 3 to go this way, right? And -4 plus 3 would be -1. So that would be my initial amount, or where x is 0, y is -1, or f of x is -1, right? And you can actually see that right here, our -1. But if I have my common difference, which I already found out is a -3, it's easy, -3x in my initial amount is -1. So what I did here, I could have also found through all of that.
I can just find the initial amount and I know what to do.
Right.
I'm golden.
Right? So it was really easy to just work backwards one step to do the initial amount. So that makes it a lot easier for us. It's the difference between using a screwdriver and a drill. Give me the drill.
Give me the drill. All right, let's try it again. I get an easier one this time because right off the bat I notice that there is an initial amount. So that is awesome. Again, it says write the function. So a function means I'm doing f of x. And if I'm doing f of x, I have to first find out if it's linear or exponential. So I look at this and say, well, let's try addition first. I see it's getting bigger. So I say, okay, well, let's go +4 will give me 5, but +4 does not give me 25. So I know that doesn't work. So it can't be addition. That means if it's getting bigger and it's not addition, it must be multiplication. So I say 1 times what gives me 5? Times 5. I say, okay, let's see if that works again. 5 times 5 is 25. So I see that I have a rate of 5. And now I could do the explicit formula for geometric, or if I know that I'm doing an explicit formula for geometric, I know that formula should be f of x equals the initial amount times the rate to the x. That seems like a lot less work than what we've done before. What is my zero term? Well, they happen to have it right here. My zero term is 1. So all I have to do then is go f of x equals my initial amount, which is 1, my rate, which is 5, to the x. Oh my gosh, that's way easier, right? I can go the other way if you want to, but I don't think I'm going to. I think this is where you need to start focusing your money on. All right, Mr. Nelson, show them the next one.
Always fun. Hey, I got a pretty good one too. How do I know that this one's easier? Because I'm given an initial amount. I'm actually given an initial amount and a first term. So that's really nice for us. Because I know initial amount makes it a lot quicker for me, I'm going to go ahead with that one. So initial amount, first term, second term. I want to go with the initial amount is 18. And I need to find that common difference or ratio. Okay, so it looks like right here, we're going from 18 to 6, then from 6 to 2. It's decreasing. If I subtract there, it would be -12, but -12 does not work here, right? So it's definitely not a common difference. So now we're going to look for a ratio. And a ratio is always what you multiply by. But division might seem a little easier at first. And 18 to 6, if we're dividing, would be divided by 3 each time, right? And that does work. 6 divided by 3 is also 2. But a common ratio, remember, if I said that my common ratio is 3, that would mean that I should be increasing, because that's a number bigger than 1, right? So if I said my common ratio is 3, I should be increasing, but that's not the case. I'm decreasing, so it should be a number less than 1. So we need to change this to what we're multiplying by. And dividing by 3 is the same thing as multiplying by
1/3
over 3, right? And so my common ratio is 1/3. And if you guys remember, if you go back to your notes on what we need to use to find this equation here, our function notation, because that's what it's asking for, is a sub 0 times r to the power of x. Unless you went with the explicit equation, then you had to simplify down to this. So we have f of x equals my initial amount, which is 18. See, right there. And then our common ratio, which is 1/3 to the power of x. And now I have my function, and I'm done. Pretty simple, eh?
All right. So, again, oh, he set me up for a lose here. It's okay. I have the 0 term. Life is good. I have the first term. I like that. That's also good. Helps you out if I put there. And I have the -1 term. I don't need to really focus on that, but I need to find out what's going on here. And so I always start off with my difference. I look, I go, oh, 4 plus what makes 4?
0.
0. So my difference is 0. And so, okay, then I have a common difference. And so I could either go first term, but I have the 0 term, and so a sub 0 is 4. And then my difference is 0. And so if I have a common difference, then it's linear. And linear functions are f of x equals the difference times x plus a sub 0. And now I just have to substitute in f of x equals the difference, which is 0x plus 4. And I probably shouldn't leave like that. This is where we're going to end up going f of x, because 0 times anything is 0, and I just get 4, which is kind of what we call a Hoy. Now, technically speaking, because Mr. Nelson's going to throw me under the bus here if I don't mention it, I could also do this exponentially. You're like, huh? Because 4 times 1 is 4. And 4 times 1 is 4. So that would give me a rate of 4. But the reason why I'm not going to go any further with this is because anything to the 1 powers itself and therefore is not exponential. While it does have a rate, if the rate is 1, it's 0 slope and it can't be exponential. We'll never grow bigger or go less. And so we can't call exponential has that special kind of curve to it or curve to it. And because a rate of 1 gives me a 0 slope, I'm not going to do exponential, and I'm going to stick with linear because linear is going to give me a straight line. So, Mr. Nelson, you cannot throw me under the bus because I'm driving it. All right. Hopefully, I didn't confuse you too much. Go ahead and try the problems, and then there's another video coming up that works with more difficult ones if you need extra help.